Hello students, welcome to BioWise with Aanchal. I hope your studies are going on well. So let us begin with a new topic called metals and non-metals, which is a very important chapter for chemistry. Now let us begin with metals and non-metals. Okay, now what are metals, what are non-metals that you have already studied in your previous classes? Still, there are certain physical properties of metals and non-metals that we are going to discuss. The first property, physical property that we are going to talk about is the state. All the metals are basically solid in state, right? And non-metals are solid and gaseous in state. There is one exception in metals, that is mercury. Mercury is a metal which is liquid at room temperature, and there is an exception in non-metals, which is bromine. Bromine is a liquid non-metal at room temperature. Now what is bromine? Bromine is a halogen. You can call it bromine, maybe some people call it bromine. Now bromine is a liquid non-metal which is a reddish brown liquid, right? Now bromine is basically a halogen, right? What is a halogen? You remember group 17 elements: fluorine, chlorine, bromine and iodine, in which fluorine and chlorine are gases, bromine is a liquid and iodine is solid. These are the non-metals, right? Now state we have understood. Next one is the luster. Luster means shine, right? So metals have a unique property that they are very lustrous. There is an exception, which is lead. Lead do not have luster. It's a metal, but it does not have a luster, right? Similarly, you have non-metals which are non-lustrous, but still you have graphite and you have iodine, which are lustrous non-metals, which are lustrous non-metals. Okay, and it is a non-lustrous metal. Exceptions, you know that chemistry is a science of exceptions, so then we have many exceptions. We are going to study about them. Fine. Next one we talk about is the malleability. Malleability is a property of metals by virtue of which any metal, when it is beaten, it can be beaten into sheets. You have seen aluminium foil, how thin it is. Then you also have seen silver layer on the sweets, kaju katli and all, remember? So these all metals can be beaten into thin fine sheets. That means they are more malleable. Non-metals cannot be beaten into sheets, they are non-malleable. Now when you talk about malleability, zinc is an exception. Zinc is an exception. Zinc is a brittle metal. It is not malleable. At the same time, there is something called carbon fibers. Now, carbon fibers are the allotropes of carbon. It is a non-metal, but it is highly malleable. Okay, so these are exceptions. Next property we talk about is ductility. Ductility means, now malleability is in sheets. Ductility means it can be drawn into wires. You have seen copper wires, fine thread-like wires made up of metals which conducts electricity. So that is a property by which a metal can be drawn into wires. So here also zinc and carbon fibers are the exceptions. Zinc, being brittle, cannot be drawn into wires. That is, zinc is neither malleable nor ductile. Carbon fibers are non-metals which are malleable and ductile, but it is a non-metal. Understood? So this is how we have exceptions in chemistry. Next we talk about sonority. Sonority means, or yeah, you can say sonorous. Metals are sonorous. Have you heard the bell ringing? It gives you a continuous sound. That is called being sonorous. So metals are generally sonorous and non-metals are non-sonorous. Conductivity. Metals are good conductor of heat and electricity. Non-metals are bad conductor of heat and electricity. Now there is an exception again. Graphite, which is a form of carbon, it is a good conductor of electricity, unlike the other non-metals. Fine. Then, when I was talking about the metals and non-metals and their differences, carbon is coming too much, right? Graphite, iodine, all are exceptions. Carbon fibers are exceptions. Then again, graphite is a good conductor of electricity, but it is a non-metal, that is an exception. Diamond is the hardest substance present on earth and it is a non-metal. Right. You know that carbon has different forms. Carbon, diamond is a form of carbon, graphite is a form of carbon, coal is a form of carbon, carbon fibers are the form of carbon. They are all non-metals, but they have some specific properties. Understood? Now, metals are considered to be hard. They have high melting and boiling point. Non-metals have low melting and boiling point, but diamond is an exception here. Then if I say metals have high melting and boiling point, then you have gallium. Gallium is a metal which melts on your palm. So it has a low melting and boiling point. If I say metals are hard, then you have sodium and potassium. Sodium and potassium can be cut by knife. So they are soft metals. Understood? So in each and every property, we see that there is an exception present. Is that clear? Let me clear the board first, then we move ahead. Now, this is all about the physical properties. Then we talk about the metals and the non-metals, the chemical properties. And before going into the chemical properties, we should know that how metals and non-metals react. So, for reaction between the metals and non-metals, you should know that metals form cations and non-metals forms anions. What is a cation? Cat has got pause. So, cations are positively charged ions. And what are anions? Anions are a negative charged ion. Right. Now, metals generally, you can see any example. Metals group 1, 2 and 3. Okay. So, if I say any example like lithium, you have beryllium, then you have potassium, you have sodium, you have calcium, you have magnesium. These are all metals, correct? Now, lithium, atomic number 3, you have the electronic configuration 2, 1. Beryllium, 2, 2. Potassium, you have 2, 8, 8, 1. Sodium, you have 2, 8, 1. Calcium, it is 2, 8, 8, 2. Magnesium, 2, 8, 3, 2. 2, 8, 2. Similarly, aluminum, you have got 2, 8, 3. These are all metals, correct? Now, what you'll notice that every metal has got either 1, 2 or 3 electrons in their outermost orbit. Okay. Now, metals have 1, 2 or 3 electrons in the outermost orbit. So, they have the tendency to lose these electrons and attain a stable electronic configuration. Stable electronic configuration of the nearest noble gas, right? Of the nearest noble gas. Nearest noble gas. Right, what is happening now when suppose this aluminium loses the 3 electron, it gets the nearest noble gas configuration of neon. Similarly, lithium gets the electronic configuration of helium. Beryllium also gets for helium. Potassium gets it for the argon. Sodium gets it for the neon. Calcium for the argon. And magnesium for the neon. So, in all these cases, you can see that stable electronic configuration is achieved by losing electrons. In these cases, you can see that the closest, that is, whichever is the nearest noble gas, their configuration is achieved. That provides them stability. Why group 18 elements are stable? Why the noble gases are stable? Because they have their outermost shell completely filled, right? So they do not want to react with others. All these metals or non-metals want to attain that stability. So they react, right? So metals have 1, 2 or 3 electrons in the outermost orbit. So they have the tendency to lose these electrons and attain a stable electronic configuration. That is the reason why metal form cations. Right. Now let us see few examples. Now there is a very detailed video on ion formation. You can refer to it for the formation of ions for the first 20 elements. So you'll understand the concept better. I'll give you few examples here, like sodium. Sodium has the atomic number 11 and mass number 23. We don't need mass number right now because we are just focusing on protons and electrons. Atomic number means number of protons, and electron is equal to the number of protons because every atom is electrically neutral. So the number of proton equals to the number of electron, correct? Now when this sodium loses one electron, so what happens to the proton? Nothing happens. What happens to the electron? It is reduced by 1. 10 protons are balancing 10 electrons. There is one proton extra that provides sodium one positive charge. Similarly, when you talk about magnesium, magnesium electronic configuration is what? 282. So it loses 2 electrons to form Mg2 plus. Aluminium loses 3 electrons to form aluminium 3 plus, right? So you can see that whatever number of electrons are lost, that much charge is developed on the elements, and hence cations are formed. Now let us understand about non-metals. Non-metals, like you have nitrogen, you have oxygen, you have sulphur, you have chlorine. Nitrogen electronic configuration is 2,5, oxygen is 2,6, sulphur is 2,8,6, chlorine is 2,8,7. You have fluorine, fluorine is 2,7, right? So here you can see phosphorus. Phosphorus is also a good example, 285. In all these cases, you see they have 5, 6 or 7 electrons in the outermost orbit. So instead of giving away these many electrons, they have the tendency to gain electrons to attain the stable electronic configuration. Now if nitrogen gains 3 electron, it will have the electronic configuration 2,8. That means it is like neon. Oxygen, if it gains 2 electrons, it also gains the electronic configuration of neon. Sulphur will get 2 electrons, it attains the electronic configuration of argon. Chlorine gets the electronic configuration of argon by acquiring 1 electron. Fluorine also requires 1 electron to have the electronic configuration similar to neon. And phosphorus requires 3 electrons to get the similar electronic configuration to argon. So in all these cases, they have the tendency to gain electrons and become a negatively charged particle called anions. So non-metals have the tendency to form anions. Okay, sulfur, 2 electrons, sulfide ion. Chlorine plus 2 electrons, chloride ion. Sorry, chlorine plus 1 electron, chloride ions. Fluorine plus 1 electron, fluoride ion. Phosphorus plus 3 electrons forms phosphide ion. So for every anion, we have the addition of ide, right? Nitride, oxide, sulfide, chloride, fluoride, phosphide. But for the cations, we have the names hydrogen ion. Now, hydrogen is not a metal. Potassium ion, calcium ion, lithium ion, beryllium ion, sodium ion. Understood? So, the naming is little bit different. Okay, you can refer to the video on ion formation and you'll understand better. But this is how the metals and the non-metals form ions. Now let us talk about the reactions, that is reactivity series. Now activity series is a very important concept for metals. Okay, activity series, basically it is reactivity series of metals. right? How it reacts. So we have the list. You have K, Na, Ca, Mg, Al, Zn, Fe, Pb, H. H is a non-metal, but it is there in the reactivity series because it behaves as alkali metal sometimes. Then you have copper, mercury, Au, that is Ag, silver, Au, gold, and platinum. This is your metal reactivity series. You have to understand here what this reactivity series means, that potassium is the most reactive metal. Platinum is the least reactive metal. Okay, and this is in the order. That means whenever there is a reaction happening, the most reactive metal will displace the less reactive metal from its solution. Right. Now, for example, I'll tell you, like if suppose I have a reaction copper sulfate. You know what is the color of copper sulfate? It is a blue color solution. Okay. Now, when aluminium is added to copper sulfate solution, aluminium is here and copper is here. That means aluminium is reactive than copper. So, aluminium will displace copper from its solution and form a compound here, that is aluminium. What is the valency of sulfate? 2. What is the valency of aluminium? 3. And you have the formation of, that is, copper is left behind. Now, this is not a balanced equation. You need to balance it. 3 sulfate. Let us make it 3. 3 copper. It is 3. 2 aluminium and it is 2. Right? This is a balanced chemical equation for the reaction. You can see that this aluminium, when it is added to copper sulfate, it displaces copper and forms aluminium sulfate. Correct? This type of reaction is called single displacement reaction. Okay, single displacement reaction. Fine. Now, when you see this, there is a link of this reaction, how it looks in the description. You can just see how it looks like. Okay, so whenever aluminium reacts with copper sulfate, you have the formation of aluminium sulfate and copper. This is a single displacement reaction because aluminium is more reactive than copper. Understood? Now, I'll tell you one concept. Like for example, if I take suppose copper only, okay, copper reacts with zinc sulfate. Okay, copper reacts with zinc sulfate. What will be the reaction? Now, here you know from the series that zinc is more reactive than copper. So, will zinc be able to displace copper from its solution? Zinc will be able to displace copper from its solution. But will copper be able to displace zinc from the solution? No, because it is less reactive. So, here there will be no reaction. But when you put it in opposite way, like when you add zinc to copper sulfate, then you have a reaction like zinc sulfate will be formed plus copper will be displaced. Are you understanding these two? Which one is more reactive? That will be able to displace the less reactive metal from its compound. Why metals form compound? Because they want to be stable, correct? That is providing them stability. So, who has the priority of getting stable? Which is more reactive, which is more aggressive, right? So, the metals which are more reactive displaces the less reactive metal from their solution. Have you understood? So, there is a one question for you. I want you to write in the comment section. Okay. The question, I'll give you 1 and 2. You write accordingly in the comment section. Now, in the first reaction, you tell me what will happen if magnesium is added to zinc sulfate. Okay. And what will happen if magnesium is added to potassium sulfate. Okay. So, what will be the output? What will be the product? You have to tell me in the comment section. Let me see what you have understood. Okay. Comment section. Okay. Give the heading as reactivity series 1 and 2 because there will be few more questions coming in the video. Okay, so I hope you understood the reactivity series. One more question I'm going to do with you. Let me clear the board first. Now let us see that we have X, Y and Z. These are the elements, or these are the metals, to be more precise. Okay, these are the metals. Okay, now what happens when X reacts with Y chloride? Okay, then you have the formation of X chloride and the Y metal is left. Understood? Then if Y reacts with Z chloride, what happens? Y chloride is formed and Z is left behind. But when Z reacts with X chloride, there is no reaction. Okay, now you have to tell me which one is the most reactive metal and which one is the least reactive metal out of these three. Okay, pause the video here, solve it and then tell me the answer or check your answer. Okay, so pause the video now. I hope you got the answer. Now let me explain. Now X displaces Y from its solution. So now X is more reactive than Y. So here X is more reactive than Y. X is more reactive than Y. Okay. Y displaces Z from its solution or from its compound. So here Y is more reactive than Z. Z is not able to displace X. That means Z is less reactive than X. Right? Now Z is less reactive than X. X is more reactive than Y. So which one is the most reactive one? X is the most reactive metal and Z is the least reactive metal. Is that clear? How many of you have done it correctly? Write in the comments section that correct answer. Yes, let me see how many of you are doing it with me. Now next we'll be talking about the chemical reactions of these metals with certain things like water, acid and oxygen. Now when the metals, like the most reactive ones, when they react with water, they can react with cold water. But for magnesium to Fe, they require steam to react. Okay, lead reacts very slowly and the metals which are below hydrogen, they do not react with water. Why? Because they cannot displace hydrogen from water because they are less reactive than hydrogen. But the most reactive ones like the K, Na and Ca, they react with cold water, right? They react with cold water to form respective bases. KOH, NaOH, NaOH and calcium hydroxide plus hydrogen gas Understood? Now you have to balance the equations. You have right, this is a balanced chemical equation where you have these most reactive metals reacting with the water, cold water, to form bases directly. Now since they are forming bases directly, you can see by using litmus test whether the bases are formed or not. It will turn the litmus, since it is base, B for base, B for blue, so red litmus turns blue when added to these solutions and hydrogen gas is released. Hydrogen gas can be tested as if a glowing splint of fire is brought near the gas, it burns with a pop sound. That is a test for hydrogen, right? So this is the reaction. The metals which are below the calcium and above hydrogen, they react with steam. Right? Magnesium reacts with steam to form magnesium oxide, not hydroxide, oxide and hydrogen gas. Right? Similarly, then you have aluminium, zinc, iron, Fe plus H2O gives you Fe3O4 plus H2. Fe3O4 plus H2, right? Now balance it. This is a balanced equation. It's a reversible reaction. So you can give this arrow. This is how the reaction happens. Similarly, the below hydrogen there is no reaction with water. Next, we'll talk about acids and their reactions with metals. Next is the reaction with acids. Now, potassium and sodium, they react very vigorously with acids, right? So you have acids like HCl. You have to use dilute HCl. Okay. So this is a very vigorous reaction. And another acid that you can use is H2SO4. Both dilute acids. Fine. A short form. Always remember there is a short form called MASH. Metal plus acid gives salt and hydrogen. Okay, so when metal reacts with acid, you have the formation of KCl plus H2. H2 gas is released. So you have to balance it. Na2SO4 plus H2. Is that clear? You can see it's a single displacement reaction only. Metals, one is coming and taking away the anion and leaving one alone. So this is the reaction with the acids. And then this is a very vigorous reaction. All the lower ones, they react little bit slowly and less violently. Why? Fine. This reaction where zinc is added to dilute H2SO4 to form ZnSO4 and H2 gas. This method is used for the production of hydrogen gas in laboratory because zinc is little bit cheaper as compared to these metals. Moreover, the reaction is little bit slow. It can be easily done in the lab, and zinc is available in the form of granules, which increases the surface area for the reaction. And at the same time, there are impurities of copper present in it, which enhances the rate of reaction, which acts as a catalyst. What is the role of catalyst? Catalyst may increase or decrease the rate of reaction. Positive catalyst increases the reaction, negative catalyst decreases the reaction. So, catalysts are those substances which participate in the chemical reaction to alter the rate of the reaction without undergoing change. Understood? What is a catalyst? Write the definition of the catalyst in the comment section. Is this clear? So, what is a catalyst? That is coming in the comment section. Let me see how many of you are listening to me. Definition of catalyst in the comment section. Understood? Now let us move ahead. The last one is the reaction with oxygen. Okay, metals react with oxygen to form oxides. Okay, like this. Iron also reacts with oxygen to form Fe2O3. Fine. So just balance it. So this is the reaction of oxygen with metals. So metallic oxides are formed. Okay, you have metallic oxides are formed. These metallic oxides are generally basic in nature. I have to give you a small information about the other metallic oxide. Let me clear the board first. There are three metals, which is zinc, aluminium and lead. Okay, zinc forms an oxide ZnO Aluminum forms an oxide called Al2O3. You should not use cursive handwriting. Al2O3 and lead oxide. These oxides, these three only, okay, they are amphoteric. They are amphoteric. Rest metallic oxides, rest metallic oxides are basic in nature, okay, and these are amphoteric. Non-metallic oxides are acidic in nature. Amphoteric oxides, this means that they behave as acidic oxides as well as basic oxides, like both. For example, amphibians. Amphibians in biology we have studied, right? What are amphibians? Amphibians are the animals which live in land as well as water. Similarly, amphoteric oxides behaves as acidic oxides and also like basic oxides sometimes. That is why they are amphoteric. And how many? Only these three. Okay, understood? Yes, understood about the physical properties and the chemical properties of metals. Right, now where are these metals present in the periodic table? If I talk about the periodic table, you have different groups and periods, right? Periodic table, you have different groups and periods. You have group 1. Group 1, that means group goes this way and period goes this way. I hope you know that. Group 1 to 18 and group period 1 to 7. Now, group 1 is called the alkali metals. Alkali metals. Okay. What are present in group 1? Lina, Ki, Rabdi, Sasti and Free. This is a mnemonics, right? When we are doing, when we have done on, okay, Free. These are the elements present in group 1 from top to bottom. They all have valency 1. They all are metals. They all form monovalent cations. So this is what alkali metals all about. Group 2 is alkaline earth metals. Alkaline earth metals. What are those? Beryllium, magnesium, calcium, strontium. Then you have barium and radium. Okay. Then you have, these are the metals. Okay. Group 13 also has got metals. Then you have boron in group 3, group 13, and carbon, not carbon, and you have silicon in group 14. These are metalloids. Metalloids are those which have the property of both metals and non-metals. Please refer to the video on element, compound and mixture. The element part has all the description in detail. Okay, then you have group 17. It is a non-metal. It is a non-metal. Group 17 is halogens. Halogens, group 17, the valency is -1. You can write 1. What are those? Fluorine, chlorine, bromine and iodine. Okay, similarly you have got group 18, which is noble gas. Right? What are those? Helium, neon, argon, krypton, xenon and radon. Okay, these are the elements of noble gases. The entire topic is being already covered in the element, compound and mixture. The description, the link is given in the description. Have a look, it will be helpful. Now, when we talk about the non-metals, we have already understood about the metals, their physical properties, their chemical properties, where they belong to in the periodic table, their location, their valencies, why they form cations. Similarly, when we talk about non-metals, non-metals are non-malleable, non-ductile, non-lustrous, non-sonorous, right? Exceptions are there, we have already seen that. At the same time, non-metals belong to the group, say group 14, 15 and 16, 17, 18, right? Now, in the group, say there are metalloids like boron and silicon, which have their specific uses, and similarly in the non-metals like carbon plays a very significant role in our life. Okay, it's a molecule of life. At the same time, there are elements like halogens, which are like chlorine gas is used in swimming pools to make the water, to disinfect the water, right? And there are other non-metals also, and their uses are there, which are listed in the sheet given in the description. Then what are the uses of noble gases? Like helium. Helium is used as a mixture in the gas cylinders of the deep sea divers. Okay, since it is a non-reactive gas, so it is used as one of the components of the air, that oxygen cylinder what the divers carry in the oceans. Then krypton, neon, they are used in all kind of advertisement boards, neon bulbs, many uses of various non-metals that we come across in our day-to-day life. Fine. There is one more important topic in this chapter. The uses of the metals and non-metals are listed in the description. Go through the same. It will be helpful. Some uses of metals and non-metals, like zinc is used in galvanization. Iron is used in making so many constructive projects, building foundations. Right. So iron is a very important component there. Then you have aluminium. It is used in alloy, making aeroplanes, duralumin. Copper is used in electrical wires. Mercury is used in amalgams. What are amalgams? Amalgams are the alloy of mercury with any other metal. Any metal, if you add it to mercury, it dissolves in mercury and can be used as amalgam. Fine. In teeth, we generally use silver amalgam and all. Is that clear? Anything else that you want me to explain about the uses and the uses of metals, non-metals, and metalloids? Put it in the comment section. Okay. Another thing that we have to study is rusting. The next important topic is rusting. Now, rusting is a slow oxidation of iron, iron in presence of moisture. In presence of moisture. Okay. Now, if you have to explain this, iron reacts with oxygen to form Fe2O3. Okay. And when this Fe2O3 reacts with X molecules of water, it forms rust. Fe2O3 dot XH2O. This is called rust. Fine. So this is a metallic oxide, hence it is basic in nature. Is that clear? Now let us understand rusting by a small experimental setup. Let us take 5 test tubes. Okay, 5 test tubes. In the first test tube, let's take some tap water. Now you know that tap water is mixture of many salts, gases and all are present. So we have taken tap water. In another one, we have taken sea water. Sea water means it is salty water. In another case, we have taken boiled water. Okay, we have taken boiled water, and we have a oil film over on the top of it, oil film. Then in another case, we have taken anhydrous calcium chloride. Anhydrous calcium chloride. Anhydrous calcium chloride absorbs moisture. So it is used as a desiccator. Like in shoes and other purses, and even in plastic bottles or even water bottles, when you buy it new, you get something called silica gel. What is the role of silica gel? It is a desiccator. It absorbs the moisture present. Okay, so this is a desiccator which absorbs the moisture present. Fine. So and that is taken. And the last one, there is an iron nail which is surrounded by a zinc metal. Okay, these are the different scenarios that we have. Water is there. Now we have to judge in which of the following rusting will happen. Okay, before knowing about rusting, you should know that you should have oxygen and water. Both should be present for rusting to happen. Now you pause the video and write down in which of the following rusting will happen. Okay. I hope you have written the answers. No cheating. You have paused the video and now you are looking for the answer. Now here you see that here tap water. So it has oxygen, it has moisture. So rusting will happen. In this case, it is seawater. It will corrode the iron nail very fast. So rusting will happen at a double speed, you can say. More speed, not double. It will happen very fast. In this case, it is boiled water. Boiled water has no air in it. So no oxygen, and water is present, moisture is present, but there is no oxygen. So in this case, rusting will not happen. In this case, anhydrous CaCl2 is absorbing all the moisture. So there is no moisture for the iron nail to react. So here also there will be no rusting. In this case, zinc is a more reactive metal. So it will corrode first and iron will not get corroded. So in this case also rusting will not happen. Understood? So this is how the rusting can be explained in these 5 test tubes. So what is the criteria for rusting to happen? You should have oxygen and water both present. Understood? This is all about rusting. Now there are methods to prevent rusting. What methods? In by any means, if you can cut the supply of oxygen and water to the metal will not rust. Correct? So let us see the methods of prevention of rusting. Now, for the methods of prevention of rusting, you have a non-metallic method in which you can paint the iron. You can, that is called painting, oiling, like the machine parts can be oiled to prevent it from rusting, enameling. Then you have that is applying a layer over the metal to protect it from rusting. There are metallic methods in which you have galvanization. Galvanization is a process by which the iron metal is dipped in the molten zinc, and then the molten zinc is allowed to cool on the metal. That forms a coating over the iron metal, and thus it prevents it from rusting. Another one is tinning. That is done to where zinc is, instead of zinc, tin is used. A molten tin is taken and the iron metal is dipped in it. Right. When zinc reacts with the food acids, it forms poisonous substances. So we cannot consume it, right? That is why we use tinned products for the food particles, for the food storage. Okay. So galvanization is understood, tinning is understood. Then we have electroplating, where we apply a thin layer of the better metal over the iron to protect it from rusting. Chrome plating is a very good example. Nickel and chromium are used to form a layer on iron and bicycle handles and all to protect it from rusting. These are the methods to prevent rusting. Is that clear? Now, like iron, other metals can also react with oxygen and moisture present in the atmosphere. Right, like for example, copper utensils. Copper utensils react with the metals, with the atmospheric oxygen, carbon dioxide and water to form copper oxide, copper hydroxide, copper carbonates. Copper carbonates and copper hydroxides forms a greenish kind of layer on the metal, where copper oxide forms black spots on the metal. These are all the methods by which the metal is slowly and steadily getting corroded. Now, why we need to prevent iron from rusting? Why do you think that we have to paint the grills and the safety doors of your house? Because iron, when it reacts with oxygen and moisture, you know that chemical reactions made, the property of the original substance is lost. So iron will lose its tensile strength and the purpose of being there in the safety doors. That is the reason why we need to prevent rusting in many cases. Big ships are there, the base is made up of iron and it is moving in the sea water. You know that sea water or the salt water increases the process of rusting. So they need certain kind of protection so that they do not rust and last longer. That is why we need to have the processes or to prevent rusting. Any doubt? The other metals like copper and all also gets corroded, but that is not called rusting. Okay. Any doubt? Put it in the comment section. It will be cleared. a small video can help you to understand the concepts better. Fine. Another thing in this chapter are the uses, and the list of the uses of the metals, non-metals and metalloid will be given in the description. For anything else, if you need, please let me know. The next video will be on the topic of your choice. Please let me know if you have not understood anything. I am there to help. Thank you. Have a nice day and happy learning, children.